Great, thank you very much. Quite happy to be here today and see so many bright and happy faces early in the morning. I'm going to talk to you about some of the opportunities and developments that we've been working on in the areas of improving environmental performance of SAGD production. So I'm sure most of you here are quite familiar with Alberta's oil sands, but want to give you a little bit of context for what I'm talking to you about today. About 80% of Alberta's oil sands are too deep for mining and have to be recovered with some sort of in situ process. Today, in situ production is over 50% of overall production and is expected to grow in the future. If you look at the chart at the bottom, that shows the GHG emissions from various fossil fuel productions predicted going out to 2030. You can see in the dark green wedge there, that's in situ production, and it's only expected to grow in the future and take a larger portion of the overall emissions. So if we drill down to a SAGD facility, where do the emissions come from? What is our challenge? About 90 to 95% of the direct GHG emissions comes from steam production. So it's the burning of natural gas to heat the water, produce the steam so that we can get the oil out of the ground. The rest of the emissions come from the balance of plants, so the water treatment, and other ancillary services on site. So some opportunities to improve this performance. Like I said, the majority of emissions come from a single point source, so carbon capture is a real opportunity here. We can also look at, are there other ways to get the oil out of the ground without steam production? And Mark's going to touch on that a bit after. The other opportunity is to continue what we're doing now, but just do it better, so improve the overall efficiency of our current processes. So I'll start by just talking about some of the opportunities within energy efficiency. Like I said, we can do what we do now, but just do it better. So improve the current technologies, make them more efficient. We can also find new technologies and take out some of the unit processes and replace them with something that operates at a higher level. We can consider treating the recycled water on site at a higher temperature. Right now, it has to be cooled to 80 degrees Celsius for treatment and has to be reheated for steam production. So what if we don't have to do that cooling and reheating and just keep it at a higher temperature? You can see that there's a lot of opportunities for energy improvement there. We can also consider the blowdown. So the steam boilers that are used on site right now make about 80% steam. That other 20% is a concentrate of all the contaminants that weren't removed in water treatment, but also had some of that residual heat. So if we can reduce that stream, we save the energy for handling it and disposing of it, but we also improve the efficiency of the natural gas that we're using to produce the steam. And lastly, a lot of in situ production, it's heat-based. So there's a lot of heat being transferred on the sites, and can we find ways to integrate that heat better or take advantage of some of the waste heat that's available on the site? When we look at these opportunities, about 1% to 3% overall GHG emissions on site is possible, or even more if we combine a lot of these opportunities together. So within AI-EES, we've developed a pretty strong portfolio on water treatment. And a lot of these technologies, as we have selected them to support, have the potential to improve the energy performance as well as other benefits on the site. Now, I'm not going to go through each of these, but I just want to highlight that on each project, it's a broad portfolio, different types of technologies, all of them are in the field, and we have a number of really strong partners helping to bring these technologies together. I'm just going to highlight one as an example. IDE is an Israel-based company. They've developed a horizontal falling film evaporator that has the potential to be 30% more efficient than conventional evaporators currently used on site. We met with them in 2013 at a conference and saw the potential fit for a SAGD in Alberta. A number of other partners also saw a similar fit, including Alberta Innovates Technology Futures, SAGD industry in general, the Alberta government, and the Israeli government. And together, this group of organizations have collaborated to advance this technology in Alberta. It started with a 1 cube a day pilot, shown in the picture on the left at the Alberta Innovates Technology Futures Lab. That pilot was quite successful in developing the cleaning and chemical dosing required to really make this technology fit for purpose at SAGD production. This next phase is currently ongoing. It's 250 cube per day pilot at a SAGD facility here in Alberta. The picture on the top right there is a picture of the unit. It's now fully constructed and ready to be shipped to site. But all these technologies have more than just GHG benefits. There's potential cost reduction, both CapEx and OpEx for many of them. They enable the use of more saline source makeup water and reducing your fresh makeup water while still maintaining or even increasing the recycle rates of the produced water on site. Most of them are smaller, they're modular, which then also reduces our physical footprint on the landscape. And the best part is all these technologies are in the field right now and likely commercial within the next 5 years, so real impacts in the near term. So I'm just going to switch tracks a little bit now and talk about carbon capture technologies. What's opportunity? Like I said, most of the emissions come from a point source, so we can really capture a large portion of SAGD emissions. When we're capturing that flue gas, it also enables us to take advantage of the heat and the water that's remaining in that flue gas and provide extra value to the site. And what about the CO2? When we capture it, is it a waste stream or is it a value-added product? Can we make a new market with that resource? If we look at this opportunity, we can reduce 80% or even more of the SAGD emissions on site. So a couple of technologies supported both by us at Alberta Innovates Energy Environment Solutions as well as CCMC, Climate Change Emissions Management Corporation, and a number of other partners. Again, I want to highlight that this is a broad portfolio, a wide range of technology types, but also that all of these are in the field at various scales. So they're being tested and piloted today. When we put these across the spectrum, you can see that a lot of different technologies, and these include others not listed previously, from R&D all the way up to demonstration. And it's a really good news story about collaboration between different organizations within the province. At AI-EES, we actively identify gaps, search around the world for technologies that we can bring back and apply to the province. And we generally work more at the applied R&D up to early demonstration, prototyping. And then in this area, we can hand it off to CCMC to take it up to that first commercial demonstration. The government itself has supported 2 commercial CCS projects. And by doing this, it facilitates them developing CCS-related policies and frameworks that will then support these other technologies moving up the development path to commercialization in the future. So one unique opportunity in this area that we've quite excited about is molten carbonate fuel cells for carbon capture. This one, right now, the molten carbonate fuel cells are commercial for power production. They have a CO2 stream that is recycled through the fuel cell to enable the transfer of electrons. It also requires an input of natural gas that is internally reformed for power production, and it's commercial for that application. But what if we don't recycle that CO2 stream? What if we take flue gas, we could pull the CO2 out of the flue gas and concentrate on the back end and it's ready for capture. So along with a number of industry partners, we've evaluated the feasibility of integrating this with a SAGD site. And what we found was a really good fit. You can capture 90% of the emissions, but you also get an output of a little bit of heat, which is never a problem on a SAGD site. You also get power, which can cover all of the power requirements of site plus enough to export back to the grid. And you get water. So again, you're handling that flue gas, you're cooling it. You get enough water that actually covers about 40% of the makeup water requirements for site, which is quite significant. When you look at cost, it's much lower than conventional amine capture technologies, and this reflects the sale of power back to the grid. So it's a revenue stream that offsets the cost of capture. Right now, we're partnering on an industry-led pre-feed for a 200 kilowatt pilot here in Alberta. In addition, there's a 2.8 megawatt demonstration for coal that's being supported by the US Department of Energy down in the US. So an exciting opportunity here. So I just want to leave you with a couple key messages. We've got a broad portfolio of technologies that have potential for significant greenhouse gas and environmental performance improvements, and they're in the field today. So that means they're commercial and have commercially available in the next few years with real near-term impacts. We collaborate globally here at AI-EES. We look around the world for the best opportunities and what we can bring back home. We also make sure to collaborate vertically. We know that we often start work with the researchers and the technology developers, but we really need to make sure that we bring in everybody along the development chain, the policy developers, the end users, to make sure that the technologies really fit the purpose that they're meant for. We want to build a toolkit. We recognize, especially in the oil sands, that one size doesn't fit all. Every site's different. Every site has its sort of unique challenges. And by building a portfolio of projects, we can allow every company, every site to sort of pick the one that best fits them to improve their environmental performance. So one final thought. A lot of these opportunities I've talked about today have significant opportunities, but if we work together, we have a chance to have a really big change in the province. And that's all. Thank you. So our next speaker is Mark Bohm. He's a manager of in-situ strategic technologies at Suncor, and he's going to talk to you about one of the opportunities for replacing steam production at SAGD sites.